Well, before we'll go deeper into Metashape software settings, I would like to explain briefly some main principles behind photogrammetry. It will give us a chance to get more consistent results inside Metashape and act more efficiently instead of choosing a way of try and errors. Following info will benefit us especially if we plan to merge DSLR footage with drone footage. So, what is photogrammetry? Let's have a look. The photogrammetry is the art, science and technology of obtaining reliable information about physical objects and the environment through the process of recording, measuring and interpreting image data. Okay, if this is a science, we should have scientific background behind the idea of measuring by using photos. Well, how old is the idea and who was the first smart person? The concept has been developed in 1480 when Leonardo da Vinci stated, "Perspective is nothing else than the seeing of an object behind a sheet of glass." So, a few centuries later, another person took his time to develop Leonardo's ideas further. Well, it was in 1850 when French scientist Aimé Lucidot, who was a well-known astronomer and cartographer, has made first attempt to use photographs for measuring purposes. Now we know that first real result of using photogrammetry has been recorded less than 200 years ago. So we can say that photogrammetry is kind of modern science, with the big names behind it. Okay, and what can photogrammetry generate? The simple explanation will be, photogrammetry allowed us to make accurate 2D and 3D measurements based on images and known sensor parameters. What is etymology? Or in other words, meaning or definition for the word photogrammetry? Well, briefly, photogrammetry consists of the three words that came from Greek language. Photo has meaning produced from light. Gram in Greek language has meaning what has been written. Metry, the process of measuring, came from Greek word metria. Now let's investigate the development of photogrammetry from 1850 till nowadays. Well, time frame from 1850 till 1950 belongs to plane table and analog photogrammetry. Those stages can be described as a usage of optical and mechanical instruments to reconstruct three-dimensional geometry from two or more overlapping photographs. Main product for plane table and analog photogrammetry would be old-school topographic maps and plans for civilian or military purposes. Next step in photogrammetry development can be seen in 1950 till 1990s. It could be considered as a time of analytical photogrammetry. Analytical photogrammetry is a usage of simple computer-based calculation that gives professionals a chance to replace some extensive work on field with optical and mechanical instruments. As a result, hybrid system with analog and digital devices combination brought to us more advanced topographic maps with elevation info and ability to work with satellite-based shots. Third step, from 1990s till now. This stage is widely known as a digital or soft copy photogrammetry. Okay, soft copy photogrammetry applied to digital images that are taken by digital camera and can be processed on the computer at any locations around the world. As a result of our tool's evolution, general users finally got a chance to generate digital maps and geometrically corrected aerial images, often called arthmosaic. So, in nowadays, digital elevation map and geo-referenced 3D images can be easily obtained by using online services or dedicated software like Metashape from Edgesoft. Well, by going a little bit deeper with photogrammetry process, we can distinguish type of photogrammetry according to camera location during our shooting process. In this classification system, we will have terrestrial photogrammetry, aerial photogrammetry, space or satellite photogrammetry. During this class, our main point of interest will be aerial photogrammetry, which has been created from UAV, more well known as drones. But just for educational purposes, we will briefly touch terrestrial and satellite or space photogrammetry as well. Okay, let's start from terrestrial photogrammetry. Well, a terrestrial photogrammetry is the branch of photogrammetry where shots are taken from a fixed and usually predefined location. In this case, the position and orientation of the camera are often measured directly at the time of the shot. Terrestrial photogrammetry often used by archaeologists, museums, and land surveyors. The terrestrial photogrammetry has been a leader for a long time in a photogrammetry business, but time passing and aerial photogrammetry becoming more and more efficient. And nowadays aerial photogrammetry starting to dominate thanks for new cost-effective technologies connected to UAV, or in other words drone technology, plus RTK and PPK processes. And aerial photogrammetry is another branch of photogrammetry where the camera is mounted on an aircraft, in our case drone. So it means photos are taken from the air by special camera attached to the drone. As a result, we will get two types of images from our drone that has been flying over the area with camera orientation vertical or oblique. Let's have a close look at types of aerial photogrammetry. Aerial photogrammetry, according to the shots, can be divided in two subcategories: metric or topographic photogrammetry and interpretive or close-range photogrammetry. Let's start with metric or topographic photogrammetry. As you can guess from the name, it mainly deals with precise measurements and calculation based on vertical aerial shots, preferably especially made by camera with mechanical shutter that let us synchronize each shot with precise coordinates based on RTK technique. These type of images are mostly in use by engineers and scientific teams and related to surveying, inspection and progress monitoring. Final output usually will be generated as a digital elevation model and orthomosaic images. Interpretive or close-range photogrammetry. Close-range photogrammetry deals with recognition and identification shapes, sizes, shadow, pattern that help us to create a 3D model that can be rotated and measured on the screen from different sides and angles. So let's classify images to fit them either in a vertical or an oblique group. Vertical aerial photos. Type of photos where the center line of the camera or lens is perpendicular to the ground. In other words, vertical aerial photographs are photographs that has been taken directly above of the target with angle from 0 to 3 degrees. So, as a result, vertical photographs can be taken from greater altitude than oblique images. Vertical aerial shots are mainly used in process of generation any of digital elevation model or DEM and for orthomosaic projects. Next one, oblique aerial photos. Type of photos where the axis of the camera or lens is tilted at the angle from 3 to 60 degrees to the ground. This type of photos bring majority info to our 3D model generation process. Oblique shots are usually only taken from low elevations, limiting their use in large surveying projects, but at the same time they are the best shots for complex shaped objects. Most common usage of oblique photographs we can find in archaeology, 3D modeling, inspections, scene reconstructions. Another huge area for photogrammetry is space photogrammetry. Space photogrammetry corresponds to the images that came from a device that is orbiting the Earth. As a result, satellite images are used rarely in the private sector and are most common for scientific research as volcano activities and the weather monitoring, plus military purposes. Our training will be dedicated to close-range aerial photogrammetry.